All right, so we're starting an introduction to the power series. You've done this before in ninth grade, so it's kind of going to be similar. But just before we start, you remember that a sequence is basically if you have a set of numbers. Oops, sorry, no plus. Okay, just a set of numbers, A1, A2, A3, and they usually increase with a common ratio. Now, what a series is just by basically adding or subtracting that set of numbers. I do have a YouTube video, it's not mine, okay, but a link on iLearn that kind of differentiates the difference between sequence and series. All right, infinite series. An infinite series is an expression of the form A1 plus A2 plus A3, blah, 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 all the way to AN. Or another way to write it is AK, where K starts at 1 and it goes all the way to infinity. The numbers A1 and A2 are the terms of the series, and A to the N, AN is the nth term, whatever that may be. Now you can have partial sums. Partial sums is taking a series but only adding up a partial amount of it. So the sums of series of numbers from 1 to n, for example, S1 you would just take A1, S2 you would take A1 and A2. The sum of three series numbers is you would take A1, A2, and A3. So the formula for partial sums is the sum of whatever the part is from 1, you're always going to start at the first term, and then you're going to go all the way to n. All right, if a sequence of partial sums has a limit s as n approaches infinity, then we say it converges to the sum of s. So if it has a set number. But if it doesn't, so if it doesn't have a set sum, we say that it diverges. Remember that it means that it goes to either infinity or negative infinity. So these terms still mean the same in this section. A geometric series. If a common ratio r in a geometric series given by this formula, a, so the first term, r to the n minus 1, and the r is less than 1, the absolute value of r is less than 1, then the geometric series, which is a1 plus a1 times r plus a2 times r squared plus a3 times r cubed plus a4 times r to the fifth plus the nth term, which is a to 1 r n minus 1, is written in this form. So the sum from n equals 1 to infinity of a1 rn minus 1. It converges to the sum of a1 over 1 minus r only if r is less than 1. So r must be less than, or absolute value of r must be less than 1. This is going to be a key. And it diverges if the absolute value of r is greater than or equal to 1. The interval, so if r is between -1 and 1, this is called the interval of convergence. Okay? So if r is between -1 and 1, this is called the interval of convergence. So here's an example. So given this geometric series, okay? So this is going to be basically 2/5 raised to the 0, right? Because we're starting at 0, which gives us 1, 2/5 to the 1, 2/5 squared plus 2/5 cubed, all the way to 2/5 to the n. This is written as the sum starting at 0 to infinity, 2/5, and we're going to keep going to n. So we're going to record our answers below. So what is r? R is obviously the common ratio in between each one, so we are multiplying each set in the series by 2/5. So r is 2/5. Based on the value of r, does the series converge or diverge? So this obviously converges. Why? Because our r, our absolute value of r is what? our absolute value of r is less than 1. Or we can say, which our r is 2/5, right? And that's less than 1. Or we can say that our r, which is 2/5, is between -1 and 1. That is the interval of convergence for our geometric series. If the series converges, put the first 10 terms of the series in your calculator, and what is the sum of the first 10 terms? So basically, you're going to go 1 plus 2/5 is 0.4, so it's going to be easier to write 0.4 plus 0.4 plus 0.4 squared plus 0.4 cubed plus 0.4 to the 4th plus 0.4 to the 5th plus 0.4 to the 6th plus 0.4 to the 7th plus 0.4 to the 8th and plus 0.4 to the 9th. And this equals 1.666. All right, if the series converges, let's calculate the sum. So because it converges, remember the sum is going to be equal to A1 over 1 minus R. And ours did converge, so then we can just write, what is our A1? Our first term in our series was 1, and it's 1 minus 0.4, which is 1 over 0.6, and it is 1.666. So if the series converges, compare your answer to question 3 and 4. What do you observe? The answers agree perfectly. All right. The second one, find R. Looking at our geometric series, we notice that 5/2 is the common ratio. So R is 5/2. Based on the value, does the series converge or diverge? It obviously diverges because R is not between -1 and 1. Obviously this is 2.5, and 2.5 is not between -1 and 1. So if the series converges, it doesn't, so we don't have to worry about that. If the series converges, it doesn't, so we don't have to worry about that. If the series converges, it doesn't, so we don't have to worry about that. Now the fact that this diverges, we know that it's gonna keep going to infinity, and it's not gonna stop at any one set number. All right, so I'm going to let you guys practice these next two, and then we'll look at your answers in class tomorrow, but they're the same, okay? Nothing different. I will tell you that this one does diverge, and this one does converge, so you will have to answer the rest of these, but here it doesn't converge, so you can't answer those questions. All right, so introduction to power series, let's take a walk. To become believers in the idea that functions can be represented by power series, because this is what we are doing. We are taking a function and we are representing it by a power series. You're going to grab your calculator or other tool to generate graphs electronically, and then verify this. So you will be asked to insert a variety of screenshots of calculations and of graphs into a document. The first few have been done for you so that you can see the pattern. So our f of 1 is 1 over 1 minus x. So rational function, and this is what it looks like if you graphed it. So what we're going to do is we are going to basically represent this function, 1 over 1 minus x, by a series, but we're going to do it slowly. So we're going to represent this function using a series, but we're going to do it one by one. So what I want you guys to do is f of 2, so you're still going to have f of 1. F of 2, you're going to graph 1 right next to it, which makes sense that it's a line. Okay? Next, in your graphing calculator, you're going to have this graph, but now we're going to change f of 2 to 1 plus x. And you're going to graph that here. Okay, we'll look at my final answers and your final answers tomorrow, but what you're going to notice is significant. So next, for graph number 4, we're going to keep f of 1, but what are we doing to f of 4? We're going to add 1 plus x squared. And we're going to keep doing it, and we're going to add 1 plus x squared plus x3, keeping in mind that this original function is still graphed as f of 1. And what you'll notice is that f of 2 actually starts mimicking the curve. The more we add to this series, the closer the series looks like the actual function. Okay, so I'll let you guys do this on your calculators, but you need to visualize it, and we'll talk about it at home tomorrow. Sorry. So you're going to keep doing this, add another number to the series, add another number to the series, and you're going to provide the screenshot in the middle column. All right, and we'll answer these questions tomorrow in class together. Because this is an introduction, I don't want it to be too long, but you can, of course, answer these questions on your own, okay? But one thing that we do want to observe, and if you don't observe this, then you're doing something wrong, is that f of 1 of x and f of 2 of x get closer and closer. So what series does the function f of 2 represent? It represents the function. What does f of 2 represent? It represents the function 1 over 1 minus x. So the idea is that 1 plus x squared plus x cubed plus x to the fourth plus blah 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 all the way to infinity will eventually be exactly the same as 1 over 1 minus x. So how are we going to represent f of 2 using sigma notation? You're just going to write it's the sum starting at 0, because you notice that we started at x to the 0, and we're going all the way to infinity. And every value, you are just adding an n. So the first value is x to the 0, the second value is x to the 1, the third value is x squared, so x to the n, 2, all right? So that's what we're going to say, which basically says this is x to the 0 plus x1 plus x2 plus x3 plus x4 all the way to infinity. All right, now you should be able to say with confidence that the function 1 over 1 minus x can be represented by the series on the domain -1 to 1. We'll refer to this as the base. This is going to be very important. You do have to remember that. So, if we know that 1 over 1 minus x can be represented by this, what about other functions? Okay? The power series for the function 1 over 1 plus x can be represented by what we know about 1 over 1 minus x. Because 1 over 1 plus x can be rewritten as 1 over 1 minus negative x. So this matches the same form as the base, right? Except instead of that x, what do we have? We have negative x. So to generate the power series for 1 over 1 plus x, we simply replace each and every x in the power series with a negative x and simplify. So it looks like this. So you replace each and every x in the series with a negative x and simplify, which ends up giving us alternating negative, positive, negative, positive. So what would the series notation look like for this power series? Like this. Okay, so if x is going to be replaced with a negative, you still have your x to the n, but now you are adding a negative 1 to the n. What about this function? Note that this function can be rewritten as take out the x, and now we have our base. So study this power series below. So we took out the x, and we still have the base. So you'd see we took out the x, and we wrote in the series for the base. And now what did we do next? To get to this, we distributed that x. And we ended up with x plus x squared plus x cubed plus x to the fourth. So here, when we plugged in for 0, okay, when we plug in 0 here, what's our first function? It's not 1. So this definitely has to be, it's not x to the 0, it has to be 0 plus 1. So it's n plus 1. Okay, so this is what changed when there's an x. So your job is to generate the power series for the following. You may need to do it on a separate sheet of paper or not. It's up to you, but you probably definitely need the space. Definitely practice this. This is the easiest of the 3 sections for this first quiz. You kind of know it already because you've done this before. Just practice this. All right, one more thing. For number 4, it kind of already sets it up for you. It shows you how to rewrite it using the base. So it's 1 over 1 minus x, which is another way to write this. So really the only thing that we are changing is the x into 1 minus x. All right, good luck.